In this video, we are going to take a look at computing a surface integral. So we've got here 9xy ds over some surface, I guess we'll call it S also. And the surface is actually a plane x plus y plus z equals 8. And it says in the first octant, which means that x, y, and z are positive. So if you want to just visualize the situation here, this is just going to be a triangle, kind of like slanted triangle. So imagine that this right here would be like 8, and then this is 8, and this is 8. And so then you just have this triangle. So that's your surface that's going to connect these intercepts, right? So this is what you got. Sorry about a little bit sloppy. But anyway, so all of this is 8. Okay, so what we need to do to solve this problem is we need to first convert to a regular double integral. And the way we're going to do that is first we're going to try to see if we can write the surface in the format z equals g of xy. So I don't usually cover the parametric representation of surfaces. I just say, okay, if the surface can be represented as z equals something, then I could do it. Otherwise, see some other upper level class. Okay, so here we got gx, which is the partial derivative with respect to x. So we need to compute that, and we're going to compute that in a second. Gy also, and then what you got is this 1 plus gx squared plus gy squared. That's going to be the differential that is going to connect the ds integral, which is the surface integral, with dA integral, which is just a regular double integral. Okay, so first of all, we need to write down that surface in the format, if possible, which of course is possible here, as z equals something. So that's just going to mean that you're going to subtract x and y from both sides, and that's your equation. So there's your g. So that's 8 minus x minus y. Now let's take the partial of this with respect to x. So that's just going to be -1, obviously, because the other terms don't have an x. And same thing, gy here will also be -1. And then to find the differential, it's going to be very simple. We just take the square root, 1 plus, so take the gx, square that, plus take the gy, square that, and then dA. And of course, when a negative is squared, that's just going to disappear. So it looks like that's just going to be square root of 3 dA. So that's the connection between ds and dA. Okay, so what else we need to make sure we understand? So because we're trying to convert this to a double integral, we need to understand that the integral cannot have a z in it, because this is just going to be x and y. So if your integrand, in other words, what you're integrating, has a z, you're going to have to substitute the value of z from the equation. So z would be like 8 minus x minus y, right? So you would substitute that. You do not need to do that here because the integrand is just 9xy. So it's not going to change. So that's just going to be 9xy. Then ds becomes square root of 3 dA. And that's what we're going to have to do. So we need to integrate. Now, integrate over what? Well, the what is going to be the projection of the surface onto the xy plane, is because it's going to be right here, right? That's going to be that triangle. So we need to set up the integral, the double integral, over that triangle. All right, so how does this triangle look like? So if we just have it a two-dimensional picture, it's going to be, let's imagine that this right here is 8, and then this right here is also 8. And this is your triangle, right? So you're trying to set up the integral, the double integral over this. So this is going to be 0. So the outside limits are the x limits, which are going to be obviously 0 to 8. Now, the insides are the bottom curve, which is just y equals 0 here, right? This is y equals 0 right here. This is a horizontal line. And then the top surface is going to be the slanted line, which is very simple to write down the equation for it, because first of all, the slope is rise over run, right? And it's negative because it's going down. And the y-intercept is 8. So this is going to be 8 minus x. Now, if you're having a little bit of trouble figuring this out, you can also think about this. Is remember this triangle, right? Part of this triangle, like this equation right here, that actually belongs to that plane, x plus y plus z equal 8. And it is actually intersection of that plane with the xy plane, right? So what is special about an xy plane? Well, that's when z equals 0. So if you were to make this 0, you're going to wind up with x plus y equal 8. And then if you solve that for y, that just gives you 8 minus x, which is going to be this limit right here. Okay, and again, we're integrating 9xy, and let's also include that square root of 3, and now we can say dy dx. Okay, so let's set that up. So this is going to be 0 to 8, and this is going to be 0 to 8 minus x. Okay, so 9xy square root of 3. All right, and then we're going to have to evaluate that. All right, so let's see if we can compute this integral. That's not going to be, I don't think it's going to be hard. Okay, so first of all, let's pull out all the constants out. So we've got the 9 and the square root of 3. We can always pull it outside of the integral. And we are just integrating xy. Okay, so let's do that. Dy dx. Okay, so first we are integrating the inside, right? And that one we integrating with respect to y. So x is like a number, but it's a constant multiple that you keep. So that's going to be x. And then y is y to the power 1. So remember, we add 1, so we get y squared. And we also divide by the same thing, but I like to put 1/2. Okay, now we draw a vertical line, and we're going to say, okay, y equals 0 to y equals 8 minus x. And then this is dx. Okay, so far so good. Okay, so, and let's take out that y 1/2 also. Why not, right? So we don't have to worry about it. Okay, so we got x, and then instead of y, we put 8 minus x squared dx. Okay, now if you think that you can start integrating at this point, that's not good because you cannot. So you have to start expanding this expression. So what is 8 minus x squared? So just remember that it's like a minus b squared. So the formula says, okay, first we square a, that's going to be 64. Then subtract 2ab. So 2 times 8, that's 16, and then x, 16x, and then plus b squared. So that's going to be x squared. Now, if you find this hard, think of it as just foiling 8 minus x times 8 minus x, and this is what you would get. Now, let's go ahead and distribute that x. So we will get 64x minus 16x squared plus x cubed. Okay, so we just have one more integration. All right, so x to the power 1 becomes x squared over 2, so that'll be 32x squared minus 16/3 x cubed plus 1/4 x to the power 4. And then we substitute in 0 and 8. Okay, well, we are basically done, but we have to convert this to a nice fraction. So let's see if we can do that. Okay, so let's get to this point and let's plug it in. So we've got 32 times 8 squared minus 16/3 times 8 cubed plus 1/4, 8 to the power 4. Okay, whatever that is, we're also going to multiply that number. So let's just open this times 9/2. Oh, it's 1536. Okay, great. So then we have 1536 square root of 3. Let's see if we can put that in.